All right, ladies and gentlemen, we're going to be going over the electron configuration and orbital notation formative. So big thing with this is there were some common errors that I saw throughout it, so we're going to address those first, okay? First things first, make sure that you are following down the periodic table as you go, okay? The second thing, a lot of you went between, we assumed that orbital notation meant that like the written out electron configuration, and that electron configuration meant the noble gas shortcut, okay? Orbital notation is going to be with the arrows so that we can see the spin on the electrons, okay? So for both of these, all right, I'm going to have my periodic table up, and we're going to be going through these as we go, okay? So again, you should have feedback on yours. This is just a tutorial of how we figured out these, okay? So the first element that we're going to be looking at here is chromium, okay? So my electron configurations start one of two ways. Okay, so you can use the noble gas configuration, and I'll be using that on some of these coming down here, or you can always start at the very top here with hydrogen, starting with R1s, okay? So if I choose to, all right, I'm going to use full electron configuration here. So I go 1s, and I'm making it my way through hydrogen, and remember, helium would be here, okay? So 1s2, all right, I make my way down, 2s2, okay? And then I make my way down to 2p6, 3s2, right? Oops. Ooh, that's a terrible 2. 3s2, 3p6, okay? So on my electron configuration for 3p6, that would end me up in argon, okay? So guys, electron configurations are always going to follow that pattern of 1s2, 2s2, 2p6, 3s2, 3p6, okay? For the most part, we crush that. All right, here is where we ran into a little bit of trouble, okay? So the first place that we ran into a bit of trouble is, remember that the d orbitals go down in the energy level number. They're actually a higher energy level because of the orbital shape, but this would be 3, 4, 5, 6, okay? And then for F, it's 4 and 5, okay? So we had some errors there, all right? The main reason that a lot of people got this one wrong, though, is remember that we have exceptions. Okay, so chromium, molybdenum, and then on this side, copper, silver, gold, those guys are the exceptions. So what that means is that they're going to take 1 from the S to either be half full or fully full. Okay, so when I look at that, all right, a lot of you wrote 4s2, 3d4. Okay, but that's not how it's going to be, because they're going to take 1 from the 4s to have half full d. Okay, so it should really be 4s1, 3d5. Okay, so that was the main error with that. All right, then with my orbital notation, okay, rule of thumb, my s's always have 1 line, my p's have 3. My D's have 5 lines, and my F's have 7, because we can fit 2 electrons in each line, okay? A reminder with that, you do need to draw all lines, regardless if you're going to fill all of them, okay? Because they're going to be single before they mingle, okay? So with that, then, you need to make sure that you are including all the lines, because a lot of you try to put all the electrons on like the smallest amount of lines, okay? They're not going to do that. They're going to want to fill each empty seat just like on the bus, okay? So for the most part, you guys did really great with the start of electron configurations, the 3S's, the 3P's, all that good jazz, okay? Where we ran into the most trouble, again, was either with the exception or with not drawing enough lines, okay? So my 4S would have 1, okay? And then my 3D, I'm going to draw all 5 lines, okay? Regardless, even if I just had 1 in my 3D, I'd be drawing all 5 lines, right? But in this case, we have 1 electron in each line, okay? So that was the correct answer for chromium, okay? From here on out, I'm going to be using the noble gas configuration for both, just because chemists are lazy. All right, so let's make our life a little easier. So we're going to find antimony, okay? So with this, when I do my electron configuration, I need to find the last P6 I would have gone through, okay? So this is the one I'm trying to find here, okay? I'd come back and I'd look in my noble gases, right? And the last noble gas that it made its way through would be krypton, okay? So I can do my brackets for krypton, so Kr, okay? And then I do need to include everything after that, okay? So after Kr, right, on my periodic table, okay, I would go into 5s2. I go all the way 4d10, okay? And then I'm going to end up with 5p3. Okay, and that would get me to antimony, okay? And if I wanted to do the full electron configuration, I could. It'd be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and then I would have the rest, okay? So that 4p6 would get me to krypton, all right? So I can just put it in the brackets, all right? I can do the same thing for the orbital notation, okay? But again, this is a prime example where if we didn't draw the correct number of lines for the P's, okay, then we doubled up, and we don't want to double up. They all want to be as single as possible, okay? So that is where we're going to draw 3 separate lines for the P, right? And that's going to allow us to, if you're me, run out of room, okay? That's going to allow us to give 1 electron per line, okay? All right, potassium by far was the one that most people got right. Oops. So again, I'm going to do orbital notation just to keep this video pretty short. Potassium, lovely 4s1. All right, so the last one that it went through for our noble gases would be argon. So I would just write AR, and then it's 4s1. Okay, so then this one's really easy. Oops. And again, this was the one that most people got correct. Okay, so last but not least, we had uranium, and this by far was the most challenging, especially for those of you that wanted to do the full notation. Okay, that's a lot of work. I'm going to do orbital noble gas notation again. So uranium's all the way down in the F group, okay? So we would have to go through a ton of things to be able to get down to the F group, okay? So some of you, I'm assuming this came off the internet, but the lanthanide and the actinide itself actually technically do belong in the D. So there, I'm going to show both ways. I do accept both ways because of the way that we teach this. So uranium's all the way down in 5F, okay, which means it technically lives right here, okay? So the last P6 that would have been gone through would be radon. So you can go RN for both of them, okay? And that contains a ton of electron configurations, and if you would like to see all of those, I can write them out for you at some point. Just let me know, okay? So with that, all right, we would have to go to the last spot that it walked that we went through, okay? So after radon, we'd go 1, 2, 3, 4, 5, 6, 7. We'd be in 7s, okay, 2, because we go through both, okay? And then we drop down to 4F, 4. Okay, I did, however, accept if you technically, all right, the technical way, you can write it 2 ways. There is 1 electron will go into the D orbital before it goes into the F, all right, but how it's sectioned, I do accept this way as well, all right. The other way, though, that I did accept was this, S1, oops, sorry, 7S2, 6D1, 4, wow, 5F3. Okay, so I accepted both. This is probably the more correct way to write it, but I do understand why we... Jeepers creepers, I'm just making errors left and right on this one. Okay, this should be 5F4. Sorry, guys. So 7S2, 6D1, 5F3. Okay, so I also accepted that one. This, again, was another example where you needed to draw out... every single part, okay? So if I do draw my 6D, okay, it would have to be 6D with 1 electron in it, still drawing out the 5, Okay, and then for my 5F, 2, 3, 4, 5, 6, 7, because I ran out of room. And I would do my 5F here, and I would still put the 3 in. Okay, so yes, you still need to draw every single one of those lines, regardless if you're going to fill them or not. Okay, sorry about the errors on the last one, guys, but it should be 5F. If you have any questions, please let me know, but hopefully this helped you understand it a bit more. If we need more example videos,